Our next speaker is a PhD candidate here at the MIT Sloan School. He's already made some really remarkable discoveries about what's going on at the very high end of the income distribution, actually all throughout the income distribution, but in particular at the high end there's some remarkable power law effects that are seemingly becoming more important. He can describe in a little bit more detail. Fun little known fact about Guillaume Saint-Jacques. He previously to coming to MIT, he worked closely with Thomas Piketty in France on some of the related data sets. So he's been diving into this for some time. Please join me in welcoming Guillaume Saint-Jacques.
Thank you. Hi, so I'm going to be presenting this paper joint with Eric. And we're concerned about something similar to the previous paper, which is, what's happening with IT and work, essentially. How is IT influencing the income distribution? The approach is a bit different. We're kind of taking a step back and looking at the shape of the entire income distribution. And the upside of that is actually that you can really tell what's going on at the top. You can see really, really high incomes, and you can tell exactly what's happening to them. The inequality literature is at this interesting state right now where, on one hand, there's like a really strong agreement about some main facts. And people agree that, yes, income inequality has happened. Between 1970 and today in the US, especially in terms of wages, there's been a tremendous increase. And on the other hand, there really isn't that much of an agreement in terms of a theory, of what's the main driving force of inequality. And there's papers arguing that it's about social norms that are changing, or it's taxes, or it's institutions, or some papers arguing that it's technology. So just to get back just kind of quickly on the facts that everyone agrees on, just to kind of set the stage and give an idea of like the magnitude of what we're talking about here. So there are many, many ways to represent inequality. I like this one where you just essentially you take all the tax files, everyone who files taxes with the IRS, you rank them from like lowest income to highest, and you just take the top 1% of those, compute the average, and divide that by the average in the bottom 90%. So the way you would kind of like read this thing, you would say, well, in 1960, a top 1% earner was making about 12 times more than a bottom 90% earner. And if you look in 2007, 2008, this ratio has jumped from 10, 12 to over 35. So that's a really, really dramatic increase in the spread of incomes. And what's interesting is that there's also something happening even if you don't look at capital income, because a lot of the discussion is, well, it's about stock options, it's about capital returns. If you just look at wages, and we're talking about wages the way they're declared, they're reported to the IRS, there's still a tremendous level of action. So a top 1% wage earner was making 7 times what a bottom 90% wage earner was making in 1960, and this has jumped up all the way to over 20. So even if you just focus on wages and forget the capital stories for a second there, there's a tremendous there's something really, really strong happening there. And so on this paper, we're just going to focus on the wages and as reported to the IRS. So since I'm going to be talking about income distributions, I thought it might just be a good idea to quickly show you what it actually looks like. So this is a density plot in log scale of the income distribution, IRS data as well, in 1960 and 2008. So the first thing you can notice is that the concentration in 1960, which is like the orange-yellow line, is much stronger than it is today. And so you have a lot of people making around some sort of like modal income. And in 2008, it's really, really, really spread out. There's much, much more inequality. There's a much, much, much higher spread of income. So that's the first thing that's interesting. The second thing is, if you look at this, so you're in log scale here, so it looks kind of like, it looks log normal, essentially. It looks normal in log scale. And it's kind of interesting in its own right, because most of the things we know about people, height, IQ, physical strength, most of these things we know, they're normally distributed. And yet when you look at income, it's really, really skewed. It's log normal. And so, why is that? And it's an old question. Pigou was asking in 1932, and people have still kept bringing new answers. And I think it's an interesting thing. And the last thing you can see here, is that there's really something happening in the tail, which is if you look at the tail. So the tail in 1960 stops around here, and 2008 it goes all the way to well over 100 million. And so the very, very top of the distribution has been really expanding dramatically. So this might not be the best way to see what's happening in the tail, so I'll just offer a different representation that I think is quite telling. So one of the ways, and Piketty did that actually, is you can just look at income shares, which is you take all of wages that are reported to the IRS, and you look, well, what does that group of the population earn in terms of the share of total income? So if you take all tax returns and you kind of like separate them in 4 different groups, the top quarter, the bottom quarter, and the 2 middle quarters of of tax returns. The top quarter, you see, they were making 55% of total wages in 1960, and this goes all the way up to close to 70% in 2008. And what's interesting is like all the other quarters are decreasing. I mean, this is just income share. This says nothing about absolute levels. I'm not saying everyone's worse off. I'm saying they're making a smaller share of income. And what's interesting is like if you do the same thing, but you zoom in 10 times. So instead of taking the whole population, you do the same quarter thing, but only on the top 10%. So you throw out the bottom 90%, look at the top 10%, cut it up in 4 pieces, and look at what's their relative contribution to total wages. And what's kind of interesting here is that really all of the action is at the top. The top quarter, so essentially if you think about like percentiles, it's between 97.5 and 100. Essentially, they're the ones who have most of the increase in income share, and the other groups, there's really nothing much happening. And what's really interesting is that you can zoom in quite a few times. So if you zoom in 10 times, look at the top 1%, do the same analysis, you get the same pattern. 10 more times, top 0.1%, you do the same pattern. And what's cool with IRS data is you can do that because we have really good data for that. Zoom 10 more times, same pattern, and 10 more times. So we're talking about like 360 people here. It's really small. You see the same pattern. And so, well, why isn't that interesting? Well, first it's striking, but then it's also, that's evidence of a power law. So I showed you before, it looks roughly log normal, the income distribution, and the log normal distribution does not give you that. This is essentially evidence that there's a power law going on. And power laws is something that we happen to see a lot in the digital economy. And this is something that struck us as quite interesting. So we have this simple model where we posit that when we look at these curves, what's really happening is that there's not one economy. There's really 2 economies that work differently. There's what we call the industrial economy, where the distribution is broadly log normal, and where essentially IT acts on inequality through scale-biased technical change that Frank explained. Essentially, new machines come in and they complement skilled workers. And then there's the whole digital economy, which is much smaller, but obviously really, in terms of amount of dollars, it's large, that concerns a smaller amount of the population, and where we can see superstar effects. So one person, one top programmer just wiping out an entire market with like one really great innovation. Network effects. So people flocking to certain apps because people are already using them. And these 2 economies, what's interesting is that they produce very, very different functional forms. They produce very different distributions. So then you can go and look back at the total distribution and try to figure out, well, who's coming from the first economy, who's coming from the second one. So just very quickly, how do we get the log normal? And Frank kind of like mentioned this, but just very quickly, the idea behind like most productivity models of wages, if you're talking about the log normal, is you get it through a multiplication. So the idea is like, well, my height is normally distributed. I mean, everyone, if we take all our heights, it's probably normal. Intelligence, everything, and yet our income is log normal. Why? Well, because I guess at least theoretically, you would think that your wage or your productivity is the product of your characteristics. So to be really good, you have to be both tall and strong and intelligent and this and this and that. So there's a product of a whole bunch of different things. And what might IT do? Well, IT might actually add terms to this multiplication. So now you need more computer skills. You need different things. And so this essentially is how you get scale-biased technical change. What this does, when you add terms here, you get a larger variance in the log normal distribution. So if this is what's going on, we would expect that in the log normal distribution of income, we would see a higher sigma, a higher standard deviation, if what's going on is scale-biased technical change. Now, how do we get power laws? These fractal effects that I showed you guys. So there's really a bunch of different things and different models that can derive power laws. I'll just show you one that I think is pretty striking. It's just preferential attachment. So picture yourself picking. In the early days of the Apple Store, or you're picking a new texting app, and you have a choice between Google Talk and WhatsApp and what have you. And obviously, the choice of app is going to depend on who's using it and among your friends. I mean, my friends don't really use. I love Text Secure, but my friends don't like Text Secure, so I don't really use it that much, for example. So what's interesting with this kind of setup is that new users who get to the App Store will flock to things that already have a large user base, and so you get this kind of like rich get richer phenomenon, where the probability of attracting a new user is essentially my market share. And so if I'm big, I'm going to get bigger, essentially. So can just kind of skip the math, but just if you do a very simple simulation of what I just described, take 5 apps that have kind of like similar market shares, and you just add new users with this preferential attachment arrival. And you see that very, very quickly, after 100,000 arrivals, there's really one app that dominates, even though in this model, they're all the same. They have the same properties. They're the same, and they start with the same market shares. It's just that very quickly you get this rich get richer phenomenon. And so this is just one of the ways that the digital economy generates power laws. And it looks, from looking at developer data, that the income of app developers seems to roughly fit a power law like this. So what we're going to do now is simply assume that, well, if we think these two economies are here, how are they mixing? And we're trying to know is like, how are they mixing over time, and what's changing about them over time? So assume that everyone in this room gets a choice. I can either be in the industrial economy, or I can be in the digital economy. And for simplicity, we just assume this, that people know what kind of wage they're going to be making in either economy. So obviously that's a simplification, but it gets results that I think are interesting. So if I became a bricklayer, I would make X, and if I became a star developer, I would make Y, for example. And so people just observe both, and they choose the max of these two distributions. Once we have this set up, and it's an assumption, once we have that, we can then go back, look at the data, the IRS data, and look at basically these parameters which identify the characteristics of the log normal distribution, the industrial distribution, and the Pareto distribution. So once we have that set up, we can kind of formulate 4 simple hypotheses. The first one is just, well, our model should fit well, and it does, and I won't spend that much time on there. But the second one is like, if really the main way that IT is influencing inequality is scale-biased technical change, then what we should see is an increase in the log normal part of the economy, an increase in sigma. If that's not the case, we should see that the increase in sigma is going to slow down, and the inequality is going to come from somewhere else. Now, if the inequality is coming from the power law distribution, we should see 2 things. We should see that A, probably more and more people seem to have their income drawn from the power law distribution, so more and more people self-select into the digital economy, and then within this digital economy, it's more and more skewed. And this is basically a lower alpha parameter for the distribution. So just a quick word on the sources. The data that we're using is IRS data. And essentially, when you're doing this kind of research, you always have kind of trade-off between survey data, where you get to see what kind of job people do and get a lot of demographics, but you miss a lot of top incomes. Or you get tax data, which has fantastic sampling at the top, but doesn't have really great demographic. And so in this case, we're using tax data for the sampling. And just to give you an example, so if you pick, in one of the data sets, you pick one observation, on average, one observation somewhere in the middle of the distribution will represent 1,000 people. So that's, take 1,000 people, make them 1 point in the data. But at the top, it's only 6 people, which means we have really, really fine and granular data at the top of the income distribution. And potentially that's what we need to identify power laws. So once you have the model kind of set up, you can go through the math and derive a PDF, a CDF, and you can use different criteria to identify it. I'm not going to go through it, but the results are kind of interesting. So this is just kind of like a first cut. If you identify that max model on the IRS data, you get this. And so 2 things that are kind of striking here is that A, it seems, so this is sigma in yellow, which means this is our kind of like indicator for scale-biased technical change. And it seems that sigma is growing, but it's growing more slowly over time. The second parameter is alpha, which is our parameter that basically captures how competitive the power law is. And alpha is decreasing a lot, and when alpha is decreasing, it looks like we're out of battery. Yeah. Alpha is decreasing, you get a more competitive digital economy. So what we're seeing here is scale-biased technical change seems to be slowing, and on the other hand, the digital economy, or the superstar part of the distribution, seems to be more and more competitive within the people who are part of it. So let's test our hypotheses formally. So the first one I'll go over quickly, but essentially it turns out that our model, the max model, fits the data better than a simple log normal. And it takes a few things to establish that because of the way the IRS anonymizes their data, but maybe we have confidence that the model works better than just a simple log normal distribution. The second thing is slowing of scale-biased technical change. So I've kind of blown that up a little bit, on a different scale. This is the same sigma that I was showing you guys before, same color, and you can really see here that the scale-biased technical change has really slowed from the 1990s compared to what it was between 1960 and 1990. And of course, there's a statistical test that you can use to establish that, but essentially there's evidence that this has slowed quite a bit. So the role of IT, main role might not be through scale-biased technical change, might not be through having new machines that favor college graduates over other people. It might be through the digital economy and through essentially the superstore effect. And so on this graph, this is the number of people who are joining the digital economy according to the model, estimated from the IRS data. And it seems that that number is increasing quite a bit between 1960 and 2008. We have less than 2% in 1960 and somewhere over 3.5% in 2008. So more and more people seem to be joining an economy, and we think it's a digital economy, an economy that has a power law distribution that's very, very skewed, and that essentially doesn't really fit the models that we have for industrial models of wages. And the last one is alpha is decreasing, which means like within the power law economy, within the digital economy, it's getting increasingly skewed. Fewer people are getting higher and higher rewards, and more and more people are left at the bottom. And there's a statistical test for that, and we pass it, essentially. So the conclusion is that really, as the economy becomes more and more digitized and more networked, the shape of the income distribution is changing quite dramatically when you look at it on the data. And our model, where we say, well, these are two economies, not just one, that seems to fit the data pretty well, and we're getting basically the result that the main impact of IT, at least through this, is more through superstar effects and winner-take-all markets and network externality, so power laws, in one word, rather than just scale-based technical change. Do you guys have any questions?
Thank you,
Yeah, a couple minutes.
Yeah, so if you go back to one of your slides, percentage of people joining, that looks pretty flat from, I can't see.
Yeah, from like 1980 to 2000.
And one of the things that I see just qualitatively, just qualitatively, is that the number of people that are interested in joining venture firms, starting venture firms, is declining. And so I wonder if that, and also people feel that venture is in a very severe bubble. And so I wonder what that means, if that would show up here at all.
I mean, so yeah, this is kind of flat, and in fact, in the data, so this is not that sensitive to specification. We've tried different things, but it seems that most of the action is actually after the 80s or the 1990s. It's not people joining; it's more like the digital economy becoming more and more skewed over time. Now, what can also happen is that these need not be the same people. So one of the problems with IRS data is that we don't get to follow people over time. We get essentially a series of cross sections, and so it could very well be that some sectors are joining the digital economy and some sectors are exiting it. And potentially, you can have, if you think of the example, that's for example, the tax, people who prepare taxes, tax preparers, for example. That you can think of that as a classical job, and then all of a sudden, TurboTax comes in and replaces that market, and that becomes. And then the guy who founded TurboTax essentially does very well, and so that becomes part of the power law economy. So it might not be, and that's also one of the concerns from is that it might not be that people want to self-select always into the digital economy. It might be that it just happens to their sector, and their outside options in another sector are not as good, so they just stay where they are. Andy?
How do you explain on that same graph the huge ramp up from 1970 to 1980, which was really before we had a digital economy?
So I mean, essentially, so the exact timing of this, I will say, changes a little bit depending on how you estimate the model. So we really focus on the fact that it's just mostly comparing these 2 points. First of all, I mean, it's clearly a simplification to say that power laws are always digital economy. But if you think of, for example, superstars in music, that's also an example of a superstar phenomenon, and you would you probably place this somewhere around there with mass CDs and all that kind of stuff. So the mechanism really is not new. It's just that it seems to be touching a higher number of sectors, and it seems to be more and more skewed within these economies, if that makes sense. Yeah.
So I think this is a similar question. I'm a little confused about what you're defining as the industrial economy and the digital economy. Where is the service economy? Where is hospitality? So where is the Walmart CEO in this picture? Is that part of? Are you saying that's digital? And if so, why is that digital? And then at one point you said something about if your wage or your productivity goes up. Are you also assuming your wages track productivity because they don't, right?
Well, I mean that's no. That's a great point. So these are all assumptions. The first one is that we don't and that's the great thing and the bad thing about tax data. We don't actually get to see the Walmart CEO and be like, well, there you are, right? So essentially, I can't tell you for any individual people where they are. We just have this kind of like mix. I'm sorry?
Where's retail, hospitality, service?
Oh, so this is completely agnostic to sectors. I mean, and the way this is estimated. These are just individual tax returns that are submitted to the IRS, and we actually don't even get to see what kind of sector people work in. Yeah?
I think it's been established that in anything that develops new, there tends to be a power law relationship of outcomes, of successes that, you look at the size of car companies when they were new and so forth. So wouldn't it be more accurate to say you're looking at the developing, the new economy versus the mature economy?
That's really that.
Industrial and digital they correlate, but they're also misleading.
Yeah, that's a good point. It could be that it's going to change, but what we've shown is essentially, I guess, in the theoretical part is essentially that these are different mechanisms. So you tend to see a lot of network effects in the digital economy if you're thinking about apps, and these are kind of fundamental to the way communication apps work. So that's something that you're unlikely to see change over time because the network effect is there. So there's definitely possibly a novelty effect and something that's going to wear off. But what we're looking at, and why we use power law specifically to identify that, is because we think they're, in some sense, they identify they're fundamental to the way apps work. Network effects are, for example.
Okay, maybe one more real quick question.
Yeah. So is it more accurate to say that technology has allowed a bigger part of the economy to be affected by power laws than to say that there is a subset of the economy that didn't exist before that was power laws? Because like bond trading, when deregulation happened and technology happened, that enabled all kinds of power laws that weren't applicable for much of the period that you're talking about. So is this merely more there's the industrial economy and there's a power law economy that isn't necessarily a particular branded set of SIC codes?
No, it's not. It's not that people are necessarily shifting from one or another. There are new sectors that are appearing, and throughout the period, GDP is growing quite a bit. So there's clearly the fact that the value has increased. The way we do this,
Does technology enable a new type of income distribution as opposed to saying a new sector has a different kind of income distribution?
Yeah, so if you think of like apps, for example, which is power law distributed, that I would think of that as completely some new thing, and not really necessarily replacing an old sector.
Right. You wouldn't, like bond trading didn't have power laws in the 60s and 70s because of regulation, but it does now.
Yeah, no, these are both true. If you think of music for music distribution, it used to be not a power law. In the 1900s, you went to see the singer in your town, and that's all you had access to. And now all of a sudden, you have this mass market. So there's really both things going on, and we can't tell a difference from this data, but they're both going on. Yeah.
Yeah, I just wanted to build on what Guillaume is saying. I think that the sharp empirical results, the earlier part, is that we see that if you want to describe the income in the economy, you can well describe it as a log normal plus at the very tail a power law. Now, why? What's going on? That's more of a hypothesis that digitization is driving that. Whether it's enabling, but it may also be changes in regulation, changes in what's happening to CEO pay, which also there's in the paper it describes more about how and when that might be related to digitization. But those are more sort of hypotheses. The hard new results is this power law versus log normal and how that's changing over time. The 4 distinct tests that he did that shows that part is growing. So I just want to, I think actually this is the first time you presented this. I think that the word digital economy may be leaping ahead a little too much. Yeah. Maybe it probably should be called the power law economy. And as to why, that's something we all need to think a little bit about why it's a power law economy. So thanks very much, Guillaume. That was terrific. Appreciate sharing that.